Hey guys, so today we're going to be talking about functions. So the first thing we need to determine is if something is a function or not. So on the front of your paper you see this table right here, and the left side shows examples of things that are functions and the right side is not. So I'm going to go through each of them and show you why they are or are not a function. So when we're looking at tables here, the reason that this one is a function is because when you look in that x column, there is no number that repeats. So no repeat x's. If you look in the right-hand column for the not function and you look at the x's, there is a repeat right there and there. So 9 is repeated. So that's why it is not a function. So then, if we go down and look at the graphs, what you do is you do the vertical line test to determine if a graph is a function. So you would drag your pencil across this graph, and if it touches it twice, then that means that it is not a function. So I am unable to draw a vertical line that passes through it twice. Same with here. I cannot draw a vertical line that would pass through it twice. Same here. When I go over to not a function, right there, I draw a vertical line and it touches it twice. That's why it's not. Same with here. Not a function. Same with here. Not a function. So then when it comes to the equations, what you would do is you would go and type that into your y equals on your calculator, and then you would see if it passes the vertical line test, which it does. Same with that, same with that. With the ones over here, it would not pass the vertical line test when you graphed it. As far as the person and their social security number, the reason that's a function is because every person only has one specific unique social security number. You can't have a person having two social security numbers. And then September 20th, and a person born that day, many people are born on September 20th. So you could have multiple people having that birthday. So then we're going to talk about what a relation is. So a relation is a set of ordered pairs. A function is a type of relation with no repeat x's. So a relation is basically any graph or a table or equation that you can think of. But then a function has to be a specific type that has no repeat x's. So then you do the vertical line test. So it's a test to determine if a relation is a function by dragging your pencil across, seeing if it touches twice. And then finally, a one-to-one is a type of relation with no repeat x's or y's. So it's a very specific type of relation. It's also a type of function because it has no repeat x's. So now flip over your paper and we're going to talk about the different types of functions. So we're going to go to the bottom right and talk about this first type. So the first type in the bottom right is a polynomial. So within a polynomial, there are three subtypes. That's why there's three graphs here. So this first one is a cubic. I'm going to talk about how you can identify something from how it looks and also from the equation. So this cubic right here, it's always going to have this general shape, and I don't know what you think it looks like. Some people may think it kind of looks like a chair. There's someone hanging out. I just call it a vertical squiggly. So not a very technical term, but it always kind of have that vertical shape. Also, the equation, you know it is a cubic because it will have a cube power. So like x cubed. So I'm going to be circling the parts of the equation that make it what it is. So cubic has an x cubed. It can have something lower like an x squared. It just can't have anything higher. The next one is a quadratic. A quadratic will always look like a U, or it could be upside down. The equation, and notice I'm using f of x instead of y equals. So since we are Algebra 2 students, we're going to be using that instead of y equals. So this type quadratic has an x squared and no higher. So if it has an x cubed, it's going to be a cubic. But just an x squared, it can have lower, but nothing higher. This last type of polynomial is a linear. A linear will always look like a line. And cubic has an x cubed. Quadratic has that x squared. And so this type has just an x. So an x to the first power, but we don't usually write the 1. It can have a number before it like 5x or a number after like 5x plus 3, but the highest exponent should be 1. So that is linear. So that's the first type, polynomial. The next type over here to the left is absolute value. So if you notice, absolute value has a V shape. So it is V. It can also be upside down, like a pyramid. An equation would have an absolute value symbol. So if you remember, an absolute value symbol are those two bars. So those bars are what makes it an absolute value. You're going to have to type these into your calculator at some point. So how you do it is you hit the math button on your calculator. You arrow over to number, and then you press 1. You can also get it by hitting second, 0, enter. So whatever you find easier, but make sure you write those notes down so whenever you have to graph it that you know how. The next type is a square root. This one's different because it starts at a point and then goes forever. All the rest of them have arrows. It's just my graphing program. You can't do it. So all the rest of them go on forever and ever. But this one starts at a finite point and then goes on forever. So that's what makes it a square root. So you can put that. It's not the fanciest way of putting it, but so it starts at a point and goes forever. I've also had students say that they think it looks like the eternal eyebrow. So if that helps you remember, then great. But it's like the eyebrow that just keeps on going. Starts in the middle of your face and will never stop. An equation will have a square root in it because it's a square root graph. So if you see that symbol, it doesn't matter what's underneath it. I'll just pick something. But that square root is what makes it a square root graph. So now let's go to the next, to the top part. So the next function type on the left is a cube root. So cube root looks very similar to the cubic. So I just say it looks like a horizontal cubic. Looks like you just took it and switched the orientation of it. So the way that you know it is a cube root is because it would have a cube root symbol. If you've forgotten how to do cube root, it is math 4. So if that's something you have forgotten, I'm not going to write it, but you need to write it, that it is math 4. So the next one is logarithmic. Logarithmic, I think, looks like a cliff. Like, no, don't jump. So it kind of looks like a cliff. Notice it flattens out at this one end, and we're going to talk about what that is in a few lessons. So an example equation of logarithmic is it will have the actual word log in it. Also, sometimes it'll look like this, lnx, which stands for natural log. So how you get those in the calculator is if you look in the first column of your calculator, you will see those two buttons towards the bottom. So you just press the button. So the next one is exponential. So exponential, I don't really have anything that I think it looks like. So this one usually just swoops up. So an example of equation, if something is an exponential, if you have any kind of number, doesn't matter, but it's raised to the x power. That's how you know that it's exponential. The final type is rational. Rational is the leftovers. If it doesn't look like something else, it's probably rationals. But one of the common themes, but not always, is that it has two graphs. So if you notice, there's two of those swoop things, and that actually is created from one equation. So it usually has multiple graphs, and you may want to write that down as a note. So for an example equation, we did our whole second unit on rational expressions. And so it's just a rational expression, like, for example, x plus 5 over x squared minus 1. So what makes it irrational is, first of all, it is a fraction. And second of all, there's an x in the denominator. When you're graphing these in your calculator, you have to make sure that you put the top in parentheses and the bottom, just like how you type it into the computer during those practice problems.